Okay, I just started factoring. This is this multiplied out. And this one does mean to multiply x plus 5 times x plus 5. So if you do it the long way, it's distributing the x twice over the x and the 5 in the second parentheses, which will give you x squared plus 5x. And then you multiply 5 times everything, and you get another 5x plus 25. And of course, you combine your like terms and have x squared plus 10x plus 25 for that one. Okay, again, I will show you a shortcut in a little bit for multiplying a binomial times a binomial, at least when it's one binomial quantity squared. All right, we're going to try to do factoring now. We're going to unfoil it, basically. So we're going to need to have a couple parentheses. Now, there can be a lot of trial and error in these problems. I'm not teaching some magic secret way to do it. I am not going to do diamonds. I am not going to do grouping. I'm going to teach you how to do grouping, factoring by grouping later, but that will be because there's 4 terms, not because I split up the middle term. So if you've heard other methods, please just accept the fact that's not how I'm teaching it the way I want to teach it to you, because I want you to learn number sense and think about the factors of all the numbers. So the first term, x squared, comes from multiplying the term that goes here and the term that goes here. So that should have been an x and an x. Now we need to get the last term to be a 28. So that would come from the last terms multiplied. Since this is negative, one of them will have to be positive and one of them will have to be negative. If you've already been taught factoring and understand it, I'm just trying to teach it as if someone hasn't done a lot of factoring before and doesn't know how to do it so much. So please bear with me if you already do know how. Okay, so some kids didn't get it maybe last time they had it taught to them. So we want to think about the numbers that multiply to give us 28. And that would be 7 and 4, which is the ones you probably thought of first. It could be 2 and 14, or it could be 28 and 1. Okay, those are the numbers that multiply to give you 28. I need a pair of them, though, that will give me a negative 12 for my middle term here. Where the middle term comes from is these multiplied and these multiplied, and then you put them together. Okay, so remember how our middle term, our middle term came from the product of those and the outer ones. That was in the middle here. Okay, that's what I'm pointing at right here. So I got to pick a pair of numbers that would help me get a 12. 7 and 4 won't, 21 and 8. I need numbers that multiply to give me the last number, but add to give me the middle number. 28 and 1 won't work because they will never get me a 12 no matter how I work them. 7 and 4 would add up to 11 or subtract. You can get a positive 11 out of them, or you can get a negative 11 out of them, or you can get a 3 out of them, or a negative 3 out of them. You get what I'm saying? By adding and subtracting any particular direction. 2 and 14, I could get a 12. So I'm going to use 2 and 14. So those factors did not get used. I'm trying to do it logically and pick out the best possible choice. If you have to guess and check, you can pick wrong ones, and then you're going to have to erase and start over. Okay, now I said one of them has to be positive, one has to be negative. When I multiply here, I would get 2 times x. And when I multiply the outside ones, I would get a 14x. But what I want to do is when I put those together, I want to get, or in some way, I want to get a negative 12. Okay, so I would want the bigger one to be negative, so I'm going to put the minus sign at the end here. And I would want the smaller one to be positive, because positive 2 plus negative 14 is negative 12. This should work. Okay, so x plus 2 times x minus 14 is the correct factorization of this trinomial. Okay, let's do another one. This one's a pretty easy one because there's not a whole lot of choices for the last term. But most kids go for the factors of 4 are, wait, do you see how both of these are plus? Then these both have to be plus. Okay, I need numbers that multiply to give me 4. And most kids would pick 2 and 2. But that is incorrect because you would get 2x in the middle. You'd get 2x from the outer. And when you add 2x and 2x, you don't get 5x. All right, so that's not the correct pair to choose. So sometimes if you fill it in wrong, you just erase and start over. What's correct would be the 4 and the 1. Because then, if I multiply the inner ones, I get 4x, and the outer ones, I get 1x. 4x plus 1x is 5x. That some of you that maybe didn't get it before start to get it now. All right, this one, I'm going to need an x in the beginning of the first parentheses and the second. Numbers that multiply to give me 14 and add to 9 would be 2 and 7. 1 and 14 won't work. So 2 and 7, both of those are addition, so both of these need to be addition. Double check. In the middle terms, I'd get 2x. At the end terms, I would get 7x, and 2x plus 7x is 9x. Part of the reason some kids don't know how to factor is because they don't really know where that middle term's coming from. So that's what I'm hoping to be explaining to you. Number 5, you got a little more trouble in that 80 has quite a few factors. Okay, one of them's positive here and one of them's negative, meaning the last part's negative, which means one of these has to be positive and one has to be negative. All right, so we're going to see. I need numbers that multiply to give me 80 and add up to 2. So I've got, what numbers do you think of when you think about multiplying numbers to get 80? 8 and 10? Well, that looks like a good pair to me, but you could have done 2 and 40, right, which is too big. 4 and 20, 5 and 16. There's a lot. Okay, so a lot of kids will forget about 5 and 16 when they do this, factors of 80, and that comes up sometimes in some problems. But 5, I don't need those. I'm going to think that it's going to be the 8 and the 10. Okay? Now, because I need a positive 2, then I would like the 10 to be positive because that's going to give me 10x on my outer terms, and I'd like the 8x to be negative because if I add 10x and 8x, I get positive 2. And the end would be negative 80, so I know I'm all good. So that's the correct factorization of that. I'm going to need the page. B, these are a little more difficult because of the leading coefficient. Now the term 4x squared is not 1. Okay, we have the coefficient is not 1 anymore. We will have more options to consider, so it might take a few more guesses. But we're lucky on the first one in that the number 3 is prime, and only 3 times 1 would give you a 3. So I'm going to do 3x and x. And now I've got to work with factors of 10 at the end. Now, notice that this is a negative here, the negative 17x, and at the end, though, it's a positive 10. If I need a positive and a negative sum, I need both of these to be negative. They have to be. Okay? Now, I'm going to think of factors of 10, 2 and 5, or 10 and 1. I don't think the 10 and 1 are going to cut it. Well, maybe. No. 10. No, if I put a 10 here, I'll get 30. That's going to be too big. So let's try the 2 and the 5. So let's say I did the 5 here and the 2 here. I just want to show you how you can check if this is going to work or not. This would be negative 5x. At the end would be negative 6x. Negative 5x plus negative 6x is not 17. So then if you did it wrong like that, which you should always check, okay, this is not right. So I try again, and I'll switch the 5 and the 2. So I'll put the 2 first and the 5 second. Now in the middle, I would have a negative 2x, and the outers would be negative 15x. Negative 2x and negative 15x adds up to negative 17, and a negative 2 times a negative 5 is a positive 10, so I am done. It has been factored correctly then. You just want to check them. Okay, the next one, number 7. Kind of wrote big. We'll need 2 has only factors of 2 times 1, so we can do 2x and x. 3 only has factors of 3 and 1, so we can put in 3 and 1, but then we better check it. These are both plus, so these have to both be plus. And then I go, wait, that's going to be 3x and 2x, and that's not adding up to 7, so I'll need to switch them. And I did it wrong on purpose, so you can see why you need to do something different. Okay, so I need to put 2 down here. Oh no, I already had that. That's what I had. So I'll put 3 down here and 1 here. And now I'll get a 1x and a 6x. And oh great, that adds up to 7. So that's completed. Okay, number 8. Now I've got to worry about factors of 8 that are 8 and 1 and 2 and 4. Factors of 9, 9 and 1, and 3 and 3. So I am going to, I don't know, want an 18 in the middle. So I'm going to play around. Usually you pick the ones that are closer together. These are both plus, so these have to both be plus or addition. 2 and 4, I'll do 2x and 4x. And then I'm going to try the 3 and the 3. See if that works. Okay, let's see. In the middle, I'd get 12x. And at the end, I would get 6x. And oh, that adds up to 18. So I got lucky and got it the first time. Scott? Meaning, could I put the 4x here? You could do the 8 and the 1, but it might not work in your situation. So let's say you did the 8 and the 1. 8x and x. And then you tried using the factors of 9. Which one pair do you want to use? 9 and the 1 or the 3 and the 3? I know. That's why I didn't do them. Yeah, it doesn't work. It's got to work. You have to check it and make sure it works. Will you ever use an 8 and a 1? Is that what you're asking me? It could happen, but that would depend. All right, sure. All right, so let's say it was 8 and 1. Then the original problem would have been 8x squared plus 3x plus 24 plus 27x plus 9. That one factors to this. This is equal to that. Okay, so it would have depended what the middle term was, Scott. That determines how you do it. Okay, so I hope we're hanging in there. Okay, last one here on this. The factors of 18, 9 and 2, 3 and 6, 18 and 1. I guess, are there any more? No. Right, factors of 14, 1 and 14. Probably not going to use those. 2 and 7. And my strategy is usually to pick numbers closer together to test them first. I don't know which pair it is. You got to either do this and this, this and this. You got 1, 2, 3, 4, 5, 6 possible ways of factoring this. Okay, so you could be guessing and checking. These are both, once the negative is down here, that means one has to be positive and one has to be negative. So I usually pick the pair that's closer together if this number is not large. So I'm going to try 3x and 6x. And I have not tried to think about it. Okay, I don't remember what it was. So I would probably pick the 2 and the 7. Now look what happens. If I put the 7 here and the 2 here, do you see how this is going to be wrong right away? Because you're going to get 42 in the middle when you multiply. So I would switch those quick. Before I start writing a bunch of stuff, I'm just going to do some logic here on how I do 2 and 7 like that. That's going to give me 21 and 12. Okay, you want to have a positive 9x. So if this is going to work, the bigger one would have to be positive and the smaller one negative. Maybe I need to write things like that down here. So if I make this plus and this minus, is negative 12 plus 21 equal 9? Yep, it's done. Knowing your times tables is very important to making this easier for you. If you do not know them, this can be quite icky. All right. Sometimes you have to factor out a common monomial first. Monomial means a single term or a single factor. So you look for something in common. What's in common to the 8t squared and the 4t? 4t. Okay, so you can divide both of those by 4t. So you factor out of 4t. And I'm going to tell you right now, on the first quiz with factoring, which isn't tomorrow, it will be the 4th quiz. Tomorrow is quiz 3. This will be missed by a large number of students because they'll look at this and they'll want to do the unfoil thing, and that's not what to do. So I started because when you go back to study or look at your notes, maybe you might want to spot that that's something you better remember. 8t squared divided by 4t is 2t, and then you have to write the minus sign, and then 4t divided by 4t would be 1. So that's what that factors to. That's it. You're done. Okay, you factored out just the 4 and the t. Now, some of you that already knew how to factor may have gone ahead, and you may have 11 not completely factored. Because the first step is to look for any number that you could divide by, or any term you could divide by in each of the terms. All of those are divisible by 3, so you have to factor out a 3 first, which would leave you with 3 parentheses x squared plus 2x minus 8. Now you factor the trinomial. You just bring the 3 down, and now you're going to unfoil x squared plus 2x minus 8, that trinomial. You're going to have x and x. I would use 4 and 2. 4 times 2 is 8. And I want a positive 2x in the middle, and I need a negative 8 at the back, so I need a positive answer and a negative, a positive factor here, and a negative, plus and then a minus. 4x and negative 2x will give me the positive 2 I'm looking for, and the 4 times negative 2 will give me a negative 8. So that's factored. This would be the final answer. If you don't have the 3 factored out, it will not be considered correct. It will have something taken off because you forgot to factor out the 3. So this one, you can divide 5x squared minus 20 by 5. So we're going to factor out a 5. That would leave us with an x squared minus 4 in the parentheses. Now this is a difference of squares and is factorable. This is a special case. I'd like to point out some perfect square numbers you're going to need to know by heart. 1 is a perfect square. 4 is a perfect square. 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. And then usually we should know 400 and 900. This should be kind of like something you get memorized. What are these? Well, they're all the numbers 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, which are called the perfect square numbers. This one's 30 times 30. This is 20 times 20. This one's 15, 14, 13, 12, 10. 11, 10, 9. Okay? I will make a chart for any of you that would like one to use in the future. This is a difference of 2 perfect squares. 1x squared minus 4. 1 is a perfect square. 4 is a perfect square. So you can factor this as x plus 2 times x minus 2, and I'll show you why. If you were multiplying this out, this would be positive 2x, and if you were multiplying these out, you would have negative 2x at the end. Those wipe out the middle term. That's why a difference of perfect squares is factored as 2 binomials with an opposite sign in the middle. They're not opposites of one another. They just are the same except opposite signs between. And that's why it works. Okay, so that's one of our patterns. X squared minus B squared, A squared minus B squared, and I just said X, using other letters, can be factored as a difference of perfect squares. A plus B times A minus B. So if you're doing X squared minus 9, that can be factored as X minus 3 or X plus 3. It doesn't matter which is first. As long as you have one that's got a plus, one's got a minus. Order for these doesn't matter. This last one here, this 14, 25m squared minus 4n squared is also a perfect square, a difference of two squares. So that's 5m minus 2n n times 5m plus 2n. Now, again, I just did it differently because I want to make sure that you realize it doesn't matter which one's first, the one with subtraction or the one with the addition. That's irrelevant. Okay, am I going too fast for anyone? Okay. This is these are called perfect square trinomials. A squared plus 2ab plus b squared can be factored as a plus b quantity squared, and then if you have a squared minus 2ab plus b squared, it factors to a minus b quantity squared. So what you're noticing here is, you see how this is 6 times 6? And the middle term is 6 plus 6. If the end term is a perfect square, 6 times 6, and the middle term is the sum of those two numbers that you multiply to get the last one, then it's a perfect square trinomial. So this one factors to x plus 6 quantity squared. All right, wait a minute. I'll show you why. Maybe I should give you one more step in there. If you were factoring this, you probably would have x plus 6 times x plus 6. But when you do get a double that matches, you should rewrite it as x plus 6 quantity squared. For this one, if you factored it, it'd be x minus 4 times x minus 4, but then you need to rewrite it as x minus 4 quantity squared. Negative, right? All right, so we're going to try it. Go ahead. Okay, we're going to check that now. So I paused. I thought maybe you'd pause if you're at home, but this is a difference of squares. So this should have been 2x minus 5 times 2x plus 5, or vice versa. So I'll write 2x plus 5 times 2x minus 5. This one is a perfect square trinomial. This one is also a perfect square trinomial. Oh, perfect. Perfect. Okay, 3y plus 4 quantity squared. Now, that's how your final answer should end up. If you are unfoiling it out, though, and you wrote two of these next to each other, you just need to rewrite it at the end. All right, so whenever you do a factorization and you end up with 3y plus 4 times 3y plus 4, you would want to rewrite then that it is 3y plus 4 quantity squared. And this one, 7r, yes, minus 1 times 7r minus 1 would change, you would rewrite as 7r minus 1 quantity squared. Yes. Okay, now I need to be more specific. Okay, probably that. Okay, you see this? It means this. What's this? And that? And 12 plus 12 is? That's why it's a perfect square trinomial. I didn't say as much about that as I probably should have. All right. So let me show you something else. See these? These make the middle go bye-bye because they're opposites. That's why this is a difference of squares. Okay, see this? negative 10n, positive 10n. That's why that's a difference of difference of squares. And that's how it factors. Now, the difference between, now watch this. I want to show you how to write this quick, like write down the answer to squaring that quickly. What it means is this, right? Which would be negative 6x in the middle. So you should what you do is to do this fast, you go x times x squared, x times negative 6, and you double it, and then negative 6 times negative 6. That's the quick way to square a binomial. So what's the pattern? I could do another. I mean, I'm just showing you, so you can just look. 2x times 2x, 4x squared. 2x times 2, 4x, double it, 8x. 2 times 2. Now that one I shouldn't have done that because I've had 2's there. All right, I'll change that to a 3. Okay, so that would have been still 4x squared. This times this would be 6, doubled would be 12, and then last would have been 9. 4x squared plus 12x plus 9. All right, now that I made a big mess, try to see this again right here. This number right here, if you think about what makes this is 3y to the second, and this is 4 to the second, and 3 times 4 is 12, doubled is 24. So you can check if it's a perfect square trinomial by doing what I just did. So I'll show you another one. Let's see. Okay, so miscellaneous factor completely. Do we have this one? I want to check the quiz preview, but this is just what this one is. Yeah. That's just a normal one. And this one you need to factor out a 3. Just get started. And then this one is a perfect square trinomial because 1 times 1 is 1. 1 times 5 is 5. 5 plus 5 is 10. Double. This is x minus 5 times x minus 5, but you're going to need to rewrite it as 3 times x minus 5 quantity squared. Take some practice, guys. Once you practice, that's why, guess what your assignment is. To finish this worksheet, and then tomorrow we have our quiz. We're going to need to do 9, which is a puzzle on factoring. So right now, let's go to the quiz preview. Oops, I want to pull up the one with a key. Worksheet 7. Yes. No. Tomorrow after the quiz, it's an assignment. So just consider that 8 and 9 are assigned. Okay? Okay, I need to get for you guys the key to the quiz preview, which I thought I had open already. Which is worksheet 7. All right, or I'll do this one. I don't know which one. Come on. Maybe you know which ones you want me to go over. Just look at this one. Come on, let me get it. All right. I would like you to have extended these, so I would not make that little of a V. I would continue them further, but Kelsey, this is for you. It's for the end of class. I don't like the way that I have these not extended, but I always extend mine. These are kind of stubby. This is just, I think I just quick pulled up Ms. Hoffbauer's graphs that she'd done a long time ago. just so I could show you the answers. You know what that's supposed to do, right? Okay, anybody have a question on either of these three? And just, like I said, I always make them longer. Not going to mark off, though, if they're right. All right, these are the steps. Do we want to talk about 4 or 5? About 6 or 7 or 9, well, 6 through 9. Any particular one of those? I know I went over this one, I think, yesterday, class. Scott? F of 1. 1 is, for the second one, that'd be negative 1 minus 3. Negative 4. Did you just make a boo-boo? Sorry, hold on. Okay, then there was this one. I don't know what that mess is. Hold on. Do you want me to go over this one at all, or? All right. Values of x less than or equal to 2 for the first equation. I just make a t-chart. Put in 2. That'd be negative 4 plus 4, which is 0. So at 2, 0, we start the graph. That would be a solid dot. It's supposed to include numbers smaller than that, too. So I'm going to put in, I don't care, 0. That'd be 4. And then you could make that piece of the line. Okay, that's for values of less than 2. And then the second one, put in 2. Guys, can you quit chatting? That'd be great. Somebody over there might want to be able to hear. Negative 1/2 times 2 minus 2 is negative 1 minus 2, which is negative 3. So at 2, negative 3, that's where your open hole is. And this one has a slope of negative 1/2. So you can go down 1, right 2, down 1, right 2, down right 2. There's that. All right, number 10. Make sure you're doing union when you do your interval for the OR problem. This one was an AND. You guys have a last minute question tomorrow, we can answer it. I am still recording though. We want to go over anything here. You know where everybody is today? We got quite a few missing. Sick? Oh. All right, graph an example. I went over this one, didn't I? Oh, okay. It has a domain of 0, 5. So that'd be between 0 and 5. I'm just making a marking that off. And a range of negative 1 to 4. So it's got to be in this box I'm about to make. So if you want something, it could be from here to here. That's it. Oh, wait, down to here. Sorry, I got to go box, corner to box, corner to box. Now, it could be different than what I made, but this is an example. Okay? That makes sense? And it stops. Okay, so it would have a solid dot here and here. Okay. 13. This is not on there. I was going to go over these before the quiz tomorrow. Just remember, circles are on it. You don't have any circles on your preview. So you want to remember to go over circles. So I can just do a few examples right before the quiz if you want. And there's going to be one with a center and a point on the circle. And then a couple of lines maybe. So I'll just do these tomorrow since so many people are missing anyway. I think I'll just go over this. Just remind me I was going to do these before we start. and we'll have plenty of time to take it. So have a nice evening. I am signing off now.